Alright, so last time we talked about the electromagnetic spectrum and you took notes on the chart. And the main thing that I want you to know is the order of the electromagnetic spectrum. And a mnemonic device is something that will help you remember the order. An example would be King Henry died by drinking chocolate milk. So that's remembering the order of the metric system. Or please excuse my dear Aunt Sally, that's remembering the orders of operation for math. So here is a mnemonic device to remember the electromagnetic spectrum. Raging Martians invaded Venus using X-ray guns. So again, the electromagnetic spectrum order is radio waves, microwaves, infrared waves, visible light, ultraviolet, X-rays, and gamma rays. So again, that will help you hopefully remember the order of the electromagnetic spectrum, and you can come up with your own if that one does not work. So today we're going to be looking at wave behavior and how they interact with mediums and how they interact with each other. The first way is reflection. So when a wave hits an object and bounces off this object, so you can think of a mirror. So light is reflecting off that mirror, and that is why you see your reflection. We'll talk about that a little bit later. You can also think of this as an echo. If you yell into a space that has walls and not a lot of sound absorption, it's going to bounce off and come back to you. We have the law of reflection. So essentially what the law of reflection states is the angle of incidence equals the angle of reflection. And we're going to talk about each part of the law of reflection, but essentially what it means is when a wave is reflected, the reflective ray or wave occurs at the same angle as the source wave. So again, we're going to talk about each part of this. So the first part is the normal line. That is essentially just an imaginary line in the middle of both rays. So that would be the normal line. It's perpendicular to the surface. So right here the surface is a mirror. Perpendicular means it creates a right angle, so it is straight up. And again, a normal line is just in between. It's essentially wherever the light ray hits, the normal line goes straight up. Then we have the angle of incidence. So the angle of incidence is going to be right here. And it is an angle. So this angle here. And it is the angle formed between the normal and the incident ray. So the incident ray is whatever is causing this wave to occur. So for example, this would be a light ray. So think of this as a flashlight pointing down here to a mirror. And so that would be considered the incident ray. And if the normal was right here where the hit the mirror, that would be the angle of incidence. And then we have the angle of reflection, which essentially is the reflected ray. So it reflects off that mirror. We again have that normal wherever the ray hits the mirror, and it's going to be that angle right here. So it's the angle of reflection, and it's the angle between the normal and the reflected ray. And as you can see on this diagram, as the angle increases in size or decreases, it's going to cause the angle of reflection to also increase or decrease. So we have our incident rays over here. So let's again pretend that that is a flashlight. So we're flashing a light down onto a surface. Let's think of that as a mirror. If it was at 70 degrees, it's going to reflect at that angle as well. If it's 50 degrees, it's going to reflect at that angle as well. So that angle does not change. So depending on what angle it is initially hitting the mirror at, it's going to reflect at that angle as well. And then we have refraction. You've probably seen this before, you just maybe didn't know the name of it. So it is the bending of a wave due to moving from one medium to another. So for example, we have a straw here, and we are looking technically through 3 mediums. We're looking through air up here, glass, and then glass and water. And this is going to cause it to look like it's technically broken because it's going to be changing the speed of light as it's going through the mediums. Because we said, again, the only way you can change an object's or a wave's speed is going through a different medium, whether that be a solid, liquid, or gas. And so if you're looking at the straw in the air, you're going to be looking at it at a specific speed of light. When you look at through the glass, it's going to change the speed of light, and it's going to change essentially how the object looks. And then if you look through it with glass and water, it's going to change the speed even more, causing it to change the way it looks as well. You can also think of this as if you're in a swimming pool and you try to reach down at the bottom of the pool, the object that you're reaching for isn't going to look where it actually is because of refraction. You're looking through air and then water, so that image is going to refract, causing the image to basically be distorted. So we can look at this as a picture. So we are, again, let's say we're standing on water or in water, and we're looking down into the water. So we're going from a more dense medium. So air is technically considered less dense than, let's say, water or glass. So we are going from a less to a more dense medium. And the way that the ray is going to be affected is it is going to go towards, so we see that it's going to bend towards that medium. So instead of going straight out like it should, it's going to bend towards the medium because it is slowing down. So going from a less to a more dense medium, such as air to glass, air to water, it is going to bend towards the normal because it is slowing down. And then let's say we are going from a more dense, so let's say glass, so this is more dense, to a less dense medium. We have our ray here, and it's going to cause that ray to bend away from the normal, because from a more dense to a less dense medium, it's going to cause that light to speed up, and it's going to bend away from the normal. Instead of just going straight as it should, it's going to bend away from the normal because it's speeding up. And again, that's from a more to a less dense medium. So another way that a wave can be affected by another object is through diffraction. So instead of bending it because of changing mediums, this is bending because of an opening or a barrier. So if we look at this image here, we have a small gap or a large gap. We can see the wave right here going this way, and it is going to be bending because of that opening or barrier. You can think of an example if you are in a hallway and it is pitch black and there's a door down the hallway open and there's light on in the hallway and in that door, that light is going to bend around that open door and go into that hallway. So that light is going to bend around that door and go into the hallway. You can also do this with the sound. Let's say you're down the hallway and another person is in the room and they start talking. Well, it's going to go from that room into the hallway because that sound is going to bend through that barrier and go down that hallway. And then we have interference. This is what happens when waves come together. So there's 2 types of interference. There's constructive and deconstructive. So constructive means that the crests of both waves overlap, and that's going to cause a bigger wave. So if we have a wave here, we see that the crest and the crest, trough and the trough, crest and the crest are in the same location, so it's going to cause a bigger wave to occur. So that crest and the crest are going to overlap, causing it to become bigger. The trough and the trough are going to overlap, and that's going to become bigger. And then we have deconstructive. So think of deconstruct. That means it's going to cause it to be a smaller wave. And this is when crest of one wave overlaps the trough of the other. So we have a crest or a trough here, a crest here, crest, trough. So the opposite parts of the wave are going to be overlapping, and that's going to create a smaller, or maybe even just cause the wave altogether to go away. And that is the end of the notes today.